We're going to get started with our first tech session today. My name's Jacob Finley with Cochran Supply. Today we're going to talk about remote access, and we've been talking about this for 5 years, 10 years now. There's multiple strategies for doing it. The main thing that I've noticed in the industry is the idea of remote access has transitioned into fully doing MSP, managed service provider, software-defined networks, etc. There's a lot to learn. It's almost another entire industry. And the three presenters I have coming up today are going to get into the technology and solution that they provide. There's no right solution for this. Every opportunity is different, and every solution is kind of the best for your customer depending on the situation. We still have, some of the old patterns that we've been doing for years out there. The first pattern we see a lot is site VPN with a broad network access. You've got your technicians running around with VPN clients on their computers. That's been an issue in the past. There's all sorts of cybersecurity problems with that owners are identifying and asking you to come up with a better solution. The other option is whenever the owner's doing it themselves and they're setting up things like inbound port forward, setting up massive WANs that they have to maintain. A lot of those end up over the years and through the transitions becoming extremely flat, unsecure. So today, whenever you see these products from some of our best vendors, I want you to think about how you can provide the cybersecurity solution that your owners need, whether or not they realize they need it. And it also, protects us to make sure that we're doing the best job that we can. There's 3 architectures today. They're all a little bit different. They all fit a different solution. First up, I'm gonna have Ruben from Tridium. He's gonna come up and talk today about their built-in solution in Niagara. And then from there, we'll go on to Neve, and after that, Johnson Controls with Open Air Wall. So without further ado, Ruben.
Good morning, everyone. My name is Ruben Yanez de Leon. I'm the product manager for the core Niagara framework at Tridium. The title of this presentation is Seamless Connectivity for Modern BAS Operations. Now, that may sound like a polished marketing phrase, but what we're really going to talk about is something very practical: how building automation systems can be accessed, protected, connected, and maintained remotely in a way that is secure and scalable and easier to support. This topic matters because remote access is no longer just for convenience, and it's not just for your convenience. It's become a core expectation from building owners, from building operators, from IT departments. And as those expectations have increased, the question has changed from how do I get into this building remotely to how do we operate these systems remotely in a way that's secure, repeatable, and sustainable over time. So that's the perspective that I'd like to share with you now. Before we go further, a quick legal framing. Some of what I'll discuss will touch on future direction concepts or areas we're exploring. So this presentation is not a product announcement, it's not a commitment to deliver specific features, and not a release date roadmap. My goal here is to share how we're thinking about remote connectivity and operations in the Niagara framework, and where I believe it can create practical value for real building automation work. So, I'd like to start by sharing a little bit about my background because it shapes how I think about this topic. Before joining Tridium, I spent about 15 years as a system integrator. I started in the field, pulling wire and installing sensors, actuators, controllers, and JACEs, a lot of the products that are being showcased today. Eventually, someone handed me a laptop, for better or worse, and I moved into checkout and programming. I did service, team leadership, engineering, and project management. After that, I spent about 5 years on the owner side. I oversaw building automation systems across a national portfolio for a property management or alternative assets company. Now that gave me a new perspective, not just how do we make this work today, but how do we support it consistently, securely, and responsibly across many sites. And now for the last year, I've been at Tridium as a product manager for the core Niagara framework. So when I talk about remote access and remote operations, I'm looking at it from three angles. The system integrator trying to support the job, the owner trying to manage risk in operations, and the product side trying to help make these capabilities more secure, repeatable, and scalable. So I'm not standing here as someone who did this perfectly. I think we've talked about this a bit. But early in my career, I port forwarded from static public IP addresses directly to Niagara hosts because we needed remote access, and it worked. Then in 2012, I attended a Vicon Pro class with James Johnson, and he showed us Shodan. And that was one of those oh no moments, right? The internet could see much more than we thought it could. I've also used, and I've seen many system integrators use, remote desktop tools installed directly on supervisor PCs. Often it was TeamViewer, and it'd be the home edition because that's free, but sometimes it was something else. And it was used because it's quick, and it's useful, it's easy. But it's hard to govern, and it's hard to manage, especially across multiple users. As a systems integrator, we also had little Raspberry Pi computers, and we installed LogMeIn Hamachi VPN software, and we would install them with cellular modems, and we dropped that onto a BAS network for VPN access. It worked maybe 75% of the time, something like that, which, depending on the service call, felt like a miracle. But my point isn't that SIs are careless. My point is that remote access as a workaround is very different from remote access as a managed service. A lot of those old approaches were reasonable answers to the problems we were trying to solve at the time, but expectations have changed. So what changed is that remote access grew up. 20 years ago, remote access was often something that we, the SI, hacked together because it was useful. If I could get into a system from home instead of driving to the site, that was a win. It was a helpful workaround, mostly for the SI, and if it worked well enough, that was often good enough. But today, that's not the expectation anymore. Building owners, Building owners expect connected systems. They expect remote support, faster response, off-site resiliency, and better access to data. And their IT teams expect those capabilities to come with enterprise-grade security, clear ownership, and an architecture that they can actually approve. So seamless connectivity is no longer a nice to have. It's expected, and that's the shift. The conversation is no longer just, can I get in? It's now, can we operate remotely in a way that's secure, repeatable, maintainable, and scalable? We can't just do good enough anymore. So if we step back, the jobs themselves are familiar. These aren't new needs. We need to protect the station. Historically, that meant manual backups, local copies on a technician's laptop, maybe thumb drives, or maybe something a little more advanced, like a supervisor scheduling provisioning jobs to back up stations to that supervisor's hard drive. But we were always hoping the latest backup was somewhere useful when something failed. But the modern expectation is off-site, current, recoverable station backups. We need access to the system. Historically, that's where VPNs, port forwards, remote desktop, and DIY access methods came in, but the modern expectation is secure remote access without every site being some custom networking project. We need to connect Niagara systems. Historically, that often meant site-to-site VPNs, firewall coordination, routing rules, custom networking. Having built out that kind of enterprise-spanning network, I can tell you that isn't easy, it's not fast, and it's not cheap. And the modern expectation is Niagara to Niagara communication across locations with less friction. And we need to use the data. Historically, that meant manual exports, third-party, sometimes questionable software modules, or one-off integrations. But the modern expectation is for data to be available for applications, for analytics, and for reporting. And increasingly, we need to manage software updates remotely. Historically, that meant remote desktop, manual updates, or touching each host directly. But the modern expectation is cleaner remote software update workflow. So the jobs are familiar. The expectations, though, are higher. And when you look across all of these jobs, there's one thing that becomes clear. The connectivity pattern matters. So we'll begin with the traditional connectivity pattern that we're most all are familiar with. Someone outside the site needs to get into the BAS network. So we solve that with VPNs, firewall rules, routing, static IPs, port forwards, or some site-specific combination of all that. And again, this can work. Many of us had made it work. But the challenge is that every site became its own custom networking project. There's setup, there's maintenance, and there's customer IT coordination. And there's usually some unique detail that one person remembers 6 months later. The Cloud Suite pattern changes direction of travel. Instead of starting with how do we get into the customer's BAS network from the outside, the Niagara host initiates an outbound connection from the site using HTTPS over port 443. That matters because outbound HTTPS is a much easier conversation with IT than opening inbound access to building systems. It also means that we don't need static public IP addresses, we don't need port forwarding, and we don't need a separate VPN appliance sitting on the BAS network. In many cases, I believe the host can even use DHCP. Its IP address can be automatically assigned to it, and standard outbound internet access. So this is not a cloud for cloud's sake. The value is a connectivity pattern, less custom networking, fewer site-specific exceptions, and more repeatable foundation for remote operations. The less every site has to be special, the easier it is to build and to maintain these systems at scale. And once that connectivity pattern is in place, we can start applying it to actual jobs and integrations that owners care about. So with that framing, this is where the Niagara Cloud Suite fits. I don't look at Cloud Suite as a random collection of cloud products. I look at it as Tridium productizing the remote operation jobs that system integrators and owners have already been doing for years and trying to solve. To begin with, for protecting stations, we have Niagara Recover. It provides off-site station backups and recovery. That matters because the worst time to discover your backup strategy was informal is after a supervisor or a JACE has already failed. For accessing the station, Niagara Remote provides secure remote station access. Today, that means browser-based access into the Niagara station through a web interface without making every site its own custom VPN or firewall project. Oh, I double-clicked here. Oh well. For connecting Niagara systems, Foxy extends that connectivity pattern to Niagara communication across locations. This is where remote access starts becoming remote operations, because it's not just a person logging into a station anymore. It's Niagara systems communicating across sites with less traditional networking friction. Foxy is in beta right now with a planned general availability. So I'm being intentional about distinguishing about what's available today and what's emerging. And for using the data, Niagara Data Service helps make Niagara data available outside the station for applications, analytics, reporting, and other services. This matters because owners increasingly want the data to support broader operational decisions, not just live within the BAS. And so now, looking forward towards Niagara 5, there are two system integrator relevant directions that I want to call out. First, the Workbench station and platform connectivity through Niagara Remote. Remote access through web browser is useful, but let's be honest, as a system integrator audience, Workbench is where system integrators do most all of their real Niagara work. Engineering a station, connecting through Fox, working with the platform over HTTPS, adding software modules, maintaining the host. That's Workbench territory. Second is remote software management. This is aimed at a cleaner remote software update workflow for Niagara host. That matters because connected systems don't just need to be accessed, they need to be maintained over time. So my point is, available today, emerging today, and built for what's next, but all aimed at the same goal, making remote BAS operations more secure, repeatable, maintainable, and scalable. So when you put all those pieces together, protect, access, connect, use data, and manage, the destination is bigger than just remote access. So if I leave you with just one thought, it's this: remote access is not the destination. Remote operations is. Getting into a building remotely is useful, but it's only one part of the larger need. Modern BAS operations also means protecting the station, accessing it securely, connecting Niagara stations that are remote, using the data, and managing software lifecycle over time. And this has to work at scale, and it has to serve all three groups. It has to be secure enough for IT to approve. It has to be useful enough for system integrators to actually support their customers. And it has to be trusted by the owners who are responsible for the building, for the data, and the risk. That's the direction we're moving with Niagara Cloud Suite. Less one-off remote access and more secure, repeatable, maintainable, and scalable remote operations. Thanks.
Thank you. Up next, we're going to have Aaron Brundum from Neve come up and show you another remote access and SDN solution. Aaron.
I'm Aaron Brundum. I work with Neve. I like to describe myself as a recovering system integrator. I spent about 15 years doing programming and engineering. In the last 10 years, I've been in the software space in the built environment here. I'm excited to share a little bit about Neve and who we are. Neve is a zero-trust OT managed service platform. So you've heard the word managed service platform. What is it? What does it mean? Neve is fully dedicated to bridging the gap between IT and OT. We've got lots of great partners here. We met some new people, and I'm going to share a little bit about what we do in our software stack, along with explaining to you what's the difference between zero trust remote access and the traditional VPNs that you guys have been using for the last 25, 30 years. So Neve is a single platform. It's designed for system integrators like yourselves, and it can be used to deliver managed services, but ultimately can help you create new reoccurring revenue for your businesses. The world's changing. There's new opportunities out there for you to provide managed services to your customers, and they're asking for it today. So Neve is all based on zero trust. How many of you have heard the term zero trust? How many of you know what it means? It's kind of ambiguous. It's kind of a catch-all. There's a lot that goes into it. But basically, it's like flipping VPN upside down. When we have a VPN connection, we get access to a network, and we basically have access to everything until somebody comes in and restricts us back and chokes it down. Zero trust takes a very different approach of No, you don't have access to anything unless you're explicitly given permission to it. But there's other elements that go into zero trust. And on the slide here, you see a few icons on here. And me being a system integrator, coming to work at Neve with a bunch of former Cisco people, I had to ask a lot of questions. I knew what a firewall was. I knew what a VPN was. I wasn't exactly sure what SD-WAN was. I wasn't sure what cloud access security brokers were. And I'm here to tell you, don't worry about it. You don't have to understand what it means, because here at Neve, we've put it into a single platform. We've taken all these elements of zero trust into a platform that is cyber secure. It's SOC 2 Type 2 compliant, ISO 27001 certified. We get approved by IT departments. It's all based on zero trust, and it's providing 4 key solutions for you to help you with your business and to deliver to your customers. And the top of the stack is providing zero trust remote access. The second layer is Neve provides edge applications. We provide edge compute. I'll get into that a little bit more. It's going to make a lot more sense. We also provide turnkey cloud hosted solutions. So if you wanted to host any BMS in the cloud, we can help you do it. And then you can also use our product to completely manage the OT network. It can be your firewall. It can be your DHCP server. It could be your next-gen firewall. Lots of cool advanced features there. And so we like to call it, a single platform, helps you scale your entire portfolio, works for buildings that have 2 rooftop units, a couple backnet controllers, all the way up to university campuses. It's providing you that zero trust remote access, cloud hosting, and this edge intelligence piece. So when we get into, explaining a little more detail what the difference between zero trust remote access and VPNs are, I could sit up here and talk about it, but I actually created a cool video that probably explains it better than I could. So let's see if it works.
Let's explore a new way to lock down your operational technology, or OT, using zero trust. So, is your OT remote access really secure? For years, we've relied on one tool, but things are changing. And here's the core issue. The old way of doing things, well, it's become a huge vulnerability. Think about it. Once a user is on your VPN, they can potentially see and touch everything. So if one password gets stolen, your entire OT system could be a risk. It's that simple. I mean, this says it all, right? It's a whole new mindset for modern security. Instead of trusting people inside the network, zero trust verifies every single request, no exceptions. And this isn't just a good idea. Top agencies like CISA are now saying it's essential. This is exactly where Neve comes in. It's a ZTNA solution built from the ground up for OT. So how does Neve actually solve these huge remote access problems? Let's break it down. First up, you only give users access to exactly what they need, nothing more. No blind trust. Neve lets you regain total control. You know who is getting in and exactly what they can do. And for your vendors, access is super simple, right through their browser. No installs, no fuss. You really can't secure what you can't see. Neve gives you the deep visibility you need. So how does Neve pull all this off? Well, let's look at their products. You've got 2 options, Secure Link for rock-solid access and Secure Edge for even more power. This chart just makes it crystal clear. The old VPN model is broken. Zero trust is secure. See, Neve isn't just some IT tool. It was actually engineered for OT, where uptime is everything.
All right. That's the first time I ever tried that. And I have one more video, so hopefully that next one will go. But hopefully that's helpful in explaining a little bit and give you some context, the difference between a VPN and zero trust. We've got a lot of other resources on our website if you want to check it out, designed for you as system integrators to better understand our technology and our stack. I'm going to go over our software stack or our architecture a little bit here. And so with Neve, we have edge nodes that get installed in your building. And what the edge nodes are doing is they're providing cybersecurity for the entire OT network. And what I mean by OT, it's everything on the OT. This is not a BAS specific product. This works for CCTV, card access. We can protect Niagara AX because I know some of you guys still have some Niagara AX out there, right? And you don't have the budget to upgrade it. We can protect it. We can provide remote access to it. We can put a moat between that and access for you, along with other types of systems as well. So the first thing that goes in is our gateway, our edge device, which has got a hardened OS. It's got a secure boot, and it's fully encrypted. It's running our Node OS operating system. The next piece that gets layered in is we provide secure tunneling. We've been providing secure, encrypted, easy to use port 443 outbound for over 10 years now to connect any types of OCT systems to the cloud or site-to-site connections. It's all managed through a single portal. I'm going to show you the portal here in a minute. It's all web-based, and it's very easy to manage your devices and manage your users. It provides browser-based remote access. It's all role-based. You can enable single sign-on, so it can link into your company single sign-on or your customer single sign-on, easily enable multi-factor authentication, and it also allows for you to use tools, what we call thick client applications, like Niagara Workbench today on your laptop to access things within the building. It works with your FX programming tools. It works with your Distech GFX programming tools. It works with your Allerton tools. It works with your Delta tools. All the different manufacturers work on our system. The next piece is we provide cloud BMS. How many of you guys have provided a cloud BMS solution to a customer so far? Couple. How many have seen it in the spec? It's coming. It's coming. I guarantee you, everybody in this room is going to have somebody ask them about hosting a cloud BMS. We at Neve provide the infrastructure to do it. We make it turnkey. Your technicians, there's no difference between them setting up a station on a Dell machine versus setting up a station in the Neve cloud. We make it easy for you to do that. And the last piece is our Edge node runs a Docker environment. What that means is it can run containerized applications. We at Neve are a Niagara OEM. You can run a Niagara supervisor on that same device that is providing cybersecurity, remote access, cloud connectivity, all in one solution. We've got a large marketplace for different OT applications. I'm sure some of you guys have used Optigo networks. When you run into backnet problems, you got to do an Optigo capture. You can spin it up on a container on the Neve device. Somebody's asking for more advanced cyber protection at the local network level. Maybe you want to run Nozomi networks. We have a partnership. You can run Nozomi networks on the same device. You can run Bueno. You can have 2 clicks connected up to Code Labs. If you needed to send data up to Nantum, it's a company that was recently acquired by OpenBlue. We've got a connection and partnership to that as well within our platform. But what I wanted to do here is, in the spirit of this is remote access for your BAS, is I wanted to show you it. So I'm going to show you a demo, and on this demo, I'm not going to move my mouth or my hands, and I hope this video works.
After authenticating, you are presented with the launcher screen. The launcher screen here has tiles that are representative of endpoints. Endpoints are how you access applications in buildings, access applications running on edge nodes, and accessing applications that are potentially in cloud-hosted solutions. We've got 2 sites connected here, Neve office in White Plains, office in Montana. I'm going to spend some time to walk you through the connections we've got configured for the Montana location. I've got 3 endpoints connected, a TCP connection. This is to allow for Niagara Workbench, so I can use Niagara Workbench natively on my machine to do everything I want to do as far as programming in Niagara. I've also have an endpoint that gets me to an HTTPS connection to access graphics and remote desktop. So to access the web graphics, I simply click on the tile, a new tab in my browser opens up, and I am logging in to the Niagara supervisor. I can also remote desktop into this machine. This is a Windows machine with remote desktop setup. I click on that tile. I can enter in Windows credentials here, or I've previously stored credentials, so now I don't have to share my Windows credentials. I click continue with stored credentials, and I am presented in a new tab in the browser with a remote desktop session. And you can see I've got Niagara Workbench open on this connection here. The launcher also has other views. There's a list view and a hierarchy view. The hierarchy view comes in handy when you've got lots of sites connected. It's also used for permissioning. On the left side of the screen is access to other parts of the application. This is for workflows. I'll show you that. This is how we get back to the home screen of the launcher. We also have audit and access logs access here. We can see everything that's happened through the platform, audit-wise and access-wise. It's also very easy to search for that. On the gear icon, this is where we can manage nodes. We can see what's available. We can add nodes from here. We can dig in deeper into the nodes on the details of what its serial numbers are. It's got a visual representation of what it looks like, what the networks are connected to it, the internet connection. If this was an LTE node, you would see the signal strength, carrier information here. We can see what networks are connected to it. Its MAC table. It also has a comprehensive audit log. Everything can be edited through the gear icon. We then can edit and configure endpoints through this as well, edit and configure users, configure networks, and configure our hierarchy. You can also access your profile and our online help documents, and we, as a managed service provider, provide 24/7 support. You can have access to our support team here through the help icon. Now I'm going to quickly show you what it takes to onboard a new node. So on the top icon on the left is workflows, setup, configure, remote access. We are going to get a node. We need to connect it to the internet, connect it to an underlying system network, and then configure endpoints for remote access. Let's begin. First, we need to select a site the node is going to be installed at. I've got our San Francisco office. I need to know the node serial number. Each one has a unique serial number. I know this one's available. I click next. And now it says plug LAN B into the node into the internet. And now I'll click next and it'll validate it has an active internet connection. All right, node's validated, it's online. This is the IP address it's using. I click next. Next step, plug LAN A into the system network. This could be the BMS network, could be directly into a JACE or a primary controller, anything on the OT. I click next, and now we got to configure LAN A. So you need to know something about the network you're connecting to. So we're connecting to a BMS network. I know it's using static IPs, so I'll select that. I know this is an available IP that I can use. I can access or set it to connect to an IP address or just everything on the WAN. I've got weather service running on an Niagara station here. It needs to get out to the internet. Make it available through remote access agent. This is what we would be using for our Niagara Workbench connection. This is where I specify what ports I want to use. I only need 4911 and 5011 for platform and station. This does require another available IP address. I don't have any VLANs it's connecting to, and I need to set its cloud destination, which typically only has one, and I click add. Now I click next. Now it's validating, assigning the IP address. IP address has been validated. Now I'll click next, and now it's scanning the network, looking for IP addresses and open ports on those IP addresses. That'll be used for potential endpoint connections. Scan's complete. It found the Niagara supervisor. That's the only thing I have on this demo network. I'm going to rename this just for convenience to the supervisor. It also found 3 endpoints available or ports that are open. Port 80, we don't want to use that. Throw that in the trash. It's not the secure port for graphics. It has a remote desktop option here. I'm going to edit that. I can enable file transfer. This is where I can enable authentication to store my credentials. I'm just going to rename it here to make it easy to decipher. And then I've got web graphics on HTTPS. I'm going to actually change that name to web graphics as well. I click save, check the box next to it, click next, and it is configuring everything, wants me to confirm it. I click confirm. And now I have Neve SF, couple new tiles here, remote desktop. This is for my Workbench connection and my Niagara supervisor graphics. I click on that. I'm presented with my login to Niagara. That's Neve. That's how simple it is. Obviously, there's a lot more features that we could go over. Feel free to reach out, schedule a time to go deeper with us.
All right, that was an easy demo. I like that, kind of hard to get started. I do have a question for you, and it doesn't have to leave this room. Do you think the guys in the business track could actually do this? I gotta know. Maybe if they used to be a tech. Neve's easy. It doesn't require your engineering team to preload stuff. You can drop ship these devices to job sites. The wizard walks you through it. We like to think we make everything simple for you. Probably one of the biggest constraints you guys have as contractors right now is manpower. You might have created your own solutions. You've put some, you've got Cradle Points out there, maybe use some of these other products that are there. They're really hard to manage and maintain. So a lot of our system integrator partners here in the room have standardized on Neve, and if you talk to them, it's made their lives a lot easier. Instead of them focusing on access management of, the OT, they're spending more time optimizing chilled water plants, working on controls, and partnering with us. So at Neve, we like to call it, a single platform. It's got one layer, everything in it, provides you that zero trust remote access, the ability to do advanced edge stuff. We didn't get into that at all. And then if you need cloud-hosted solutions, we can be helpful for you with that. All right, thank you.
Thank you. Thanks, Aaron, for working through our technical difficulties. I appreciate it. All right, we're going to run up against the next session because we're running a little bit behind, but I do want to bring up Dominic from Johnson Controls Open Air Wall, show you another cool solution we've been working with lately.
Hey everybody, I'm Dominic Busa. I lead up our solutions engineering for OpenBlue Airwall, and I'm going to tell you about how you can secure building controls without the network redesign. So we're going to start out, I'll give you a bit of an intro on OpenBlue Airwall. I'll talk about brownfield building security concerns. Then we'll go into how Airwall addresses those security concerns. And I'll give you kind of an overview about what I'm going to show you in a live demo. So we've got equipment back there. You see Jeff standing next to the equipment. We're going to use that in this presentation. All right, OpenBlue Airwall. So secure your building controls without the network redesign. So with Airwall, we can protect existing building systems, so your HMI, your servers, those third-party integration devices that you might have purchased from somebody and you don't fully trust them, you don't know what their security stance is on them. You can use Airwall and isolate those devices and make it such that they have the least privileged access that they need to operate. You can control vendor and technician and employee access. So giving out remote access to your employees, your technicians, your vendors, to the devices, just the devices that they need, just when they need to access them. And you can deploy all this without major network redesign. So without needing to change those IP addresses. So not calling up that vendor or calling up your controls contractor, getting them in to change that static IP on a controller so you can put it into a different network. Without the VLAN redesign, without the firewall complexity. And so we've proven all this, and we've done this in large environments. So Penn State is one of our flagship deployments. We deployed this across 640 buildings. We reduced their attack service by almost 90%. In doing so, we reduced broadcast storm issues that they were having and dropped their alarms significantly. So now let's talk about brownfield security concerns. On the left here, and let's see if I can bring up our laser pointer. So on the left here, this is just a simple building network that I have put together that's standing next to Jeff there. It's the one with the green and-on light stack on it. And on there we have an HMI connected to an HVAC controller and an analytics gateway. So this is that third-party integration device. And so all these are currently on a flat BAS LAN, shared network. That analytics gateway is reading Modbus data from the HVAC controller. It's sending that data up to a cloud database, Grafana Cloud. And we have vendors and employees that need to access in and maybe do some updates on the controller. What I'm going to do with Airwall in the rest of this session here is I'm going to isolate that vulnerable device. I'm going to introduce microsegmentation, zero trust. So we're going to take that analytics gateway. We're going to keep its IP address as well as the other IP addresses of the other devices, but we're going to put it into its own isolated segment. And then we're gonna enable communication back to it, but just what's necessary, just to the HVAC controller, just to the cloud endpoint. We'll also show how we can do site-to-site communications. And I'll also show how we're gonna do remote access into the site for users just when they need to access those devices. Okay, so I'm gonna give you kind of the preview of what I'm gonna show you, and then we'll go do it. The first part here is we're gonna eliminate that shared network. So I'm gonna have Jeff, not yet Jeff, but when we're ready, Jeff is gonna move some cables around. He's gonna take that HMI and the HVAC controller, plug that into port 2 of the air wall. And then he's gonna take the analytics gateway, plug it into port 3. And what we're gonna be able to do with that is we're gonna isolate those 2 segments, keep their IP addresses, and then I'm gonna add back communication between those as necessary. Next, I'm gonna take that analytics gateway and we're gonna extend its capability. So we have another air wall that represents a different site, and we're gonna enable that analytics gateway to read between air walls, so across this air wall here at the first site to the air wall at the second site, and be able to collect data from another controller. I'm also going to enable site-to-cloud communications. So I'm going to enable that analytics gateway to communicate and send out data to a public internet endpoint, Grafana Cloud. And then finally, what I'll show here is how you can use Airwall for secure remote access. So we'll reach in and we will communicate with one of the devices that is protected by Airwall. So without further ado, let's do a demo. Here's a bit of a recap. I mean, I just showed you all this, so what I'll do here is I'm gonna exit out of this and we're gonna go into rolling the dice with a live demo. Okay, so on the left here, I'm gonna keep this up. This is our network architecture diagram, and we're gonna reference this a few times while I'm talking. And what I'm showing here on the right here is this is Grafana Cloud. And the takeaway that you should see here from me showing this is that there's this green line. It's kind of, it's doing this kind of sawtooth pattern. So this green line is the heartbeat of the HVAC controller that the analytics gateway is reading from. And right now, all these devices are connected to the flat BAS LAN. And so Jeff, could you do the job of switching over to protecting it with Airwall? Okay, so Jeff is moving some cables around. He's gonna connect the HMI and the HVAC controller to port 2 of the Airwall. And then, in a moment, he will do the same for the analytics gateway to port 3. Now, I'm gonna go into our Airwall conductor. So the Airwall conductor is the management component of the Airwall solution. This is where your administrator would go into, manage your network policy, do onboarding, and those type of things. I'm gonna click on the Airwall device that Jeff just connected those devices into. We can see it's online here. I'm gonna go to diagnostics, and let's check and see if Jeff did his job correctly. You still working on it? All right, Jeff's still working on it. We're probably gonna see that here. I just went to our diagnostics page and ran ping all devices, and we see that Jeff did not connect the analytics gateway. All right, let's try that again. So, what I'm trying to show you here is that we can do a lot remotely. We can also do packet captures, and so we help avoid that truck roll. So we just checked here. We made sure that all the devices that Jeff moved over are now connected to Airwall. And now let's take that next step. And so right now they're all isolated. No device can talk to no other device. And so let's add back in. Oh, you know what? I forgot to remove this. Okay, so let me just fix this really quick. So now you can believe me that the devices are in fact isolated. And what I can do is now add in the policy, the trust between devices, and make it such that this sketchy third-party analytics gateway, it only has communication to what it needs to talk to. So I'm going to add communication to the HVAC controller. It's going to be able to do Modbus reads. I'm going to give it capability to reach out to Google's DNS so that it can resolve the domain name for Grafana Cloud. And then if we go back to Grafana here, we should see that this minute trace here is tracking. And so we see a continued data flow. And so you see here that the latest heartbeat has a value of 4. That tracks with the current minute being 10:05. So it's always 1 minute delayed. So we have reestablished connectivity there. Now next, so we did this at the local site. We isolated the analytics gateway, we isolated controller and HMI, and we didn't change any of the IP addresses. Let's take this one step further, and now let's connect the analytics gateway to a different site that is using Airwall. And we're going to connect it to that server room 5 controller here. Okay. And so you see here, we're back to that page, back to that network diagram. And when we talk about giving trust and giving policy with Airwall, we stop talking about Airwalls and we focus in on devices. So this makes it really easy for us that aren't IT experts, but we know what we have in our building. So I'm going to click on Edit Trust here, and I'm going to give policy for that analytics gateway to communicate to the server room 5 controller. And we'll do another check here. I'm going to check connectivity. So we've got a lot of these diagnostic tools built in that give you peace of mind and make your job easier without having to kind of ramp up on all the technical knowledge of how some of the network communications should work. So what we see happening here is the server room controllers on the left, the analytics gateways on the right, and then in between them are their respective Airwalls. And it's checking that communication. So it's checking, is there trust between the two devices? And that's that first check here. Can the Airwalls ping their respective protected devices? Can the Airwalls actually ping each other? And what we end up seeing here is a nice green line. That's a happy green line. We do have policy. And so I'll go back to Grafana here. And now we see that the server room 5 controller is starting to get, starting to report data reads. And so I've got that same heartbeat running on that. And we see that the latest value is 6. It is 10:07, which is consistent with what we expect for it to be 1 minute behind. Okay, so we talked about local microsegmentation and isolating vulnerable devices. We talked about site-to-site communication between protected devices behind Airwalls. Now I'm going to wrap with showing you secure remote access. So we'll go back to our Airwall here, and I'm going to go to this device. So this is a device that is protecting a PTZ camera we have hanging off that TV up there. And I'm going to connect to it over Airwall using this laptop that I'm showing you on the screen here. So I've got an agent running here. What this enables me to is to make an end-to-end encrypted connection to that remote device. I'm going to first, do my authentication. So I've got multi-factor authentication set up with this. Let me get my code out so we can log into this. All right. Okay, so I'm logging in. We're authenticating. Okay, great. I'm going to confirm the remote session. Now I'm going to go back to the admin page of the conductor, our management interface. I'm going to click on the Windows agent that represents that authenticated connection I just made. And now we can see that here I am, here's Dominic, and I made a connection here at 10:08 a.m. So that's tracked. Now, let's give me, on this computer, access to that PTZ camera. Let's see if we can pick up Jeff. It looks like it's pointed at Jeff right now, so let's see if we can do that. So I'm going to go to another overlay network. So this is how we give access with Airwall. And what I've set up here is a smart device group. So this is a concept that enables us to scale out Airwall across many sites and across many users. So in here, I'm going to click and expand this, and what you'll see here, there's membership rules. So there's device match rules, and it says any Airwall that has this tag, vendor exact controls, put it into this group, and if you put it into that group gives you access to the PTZ camera. I'll go back to my user, and we see that I do have that tag. Fantastic, so I should be able to reach it. I'll go into our Airwall agent here running on the computer. I go to my devices. Here's the PTZ camera. Let's do just a quick check with ping. While that's running, I'm actually going to make that connection. We see ping is responding. And now let's see if we can actually get that camera feed to run. And so what's happening in the background here is my laptop here and that air wall are exchanging cryptographic identities. They're checking to see if it's in fact two air walls attempting to communicate. If that passes, then they check and see if the policy is allowed for those two devices to communicate. And it is. We see Jeff, and we're connected. All right. So thank you everybody for listening. This is great, and come check us out. We're over in the corner there. We'll be here until the end of the show.
Thank you.